Picture yourself riding in the passenger seat of a car. You are holding a full cup of coffee. The ride is perfectly smooth, right up until the driver suddenly slams on the brakes. The car stopped its forward momentum, but the liquid inside your cup did not. It keeps moving right into your lap. This happens because of a basic rule of physics called inertia. Inertia is just a fancy word for a simple reality. Objects in motion want to stay in motion. Unless something physically locks them down, they will keep traveling at exactly the same speed they were already going. Right now, you probably feel like you are sitting completely still, but you are actually a passenger in a massive vehicle. If you are near the equator, the planet beneath you is spinning at roughly 1,670 kilometers per hour. We never feel this incredible speed because the ride is perfectly smooth and constant. It is exactly like cruising down a newly paved highway in a luxury car with your eyes closed. To put that into perspective, you are currently moving faster than a fighter jet breaking the sound barrier. Since inertia dictates that loose objects want to keep moving, what exactly happens to us if our planetary driver suddenly hits the brakes for exactly 5 seconds? Imagine the exact moment the bedrock of Earth stops dead. The ground beneath you instantly halts, but everything resting on the surface continues moving east at that same supersonic speed. Most of the things around us are simply not bolted deeply enough into the planet's crust to withstand this. Trees, cars, and even the heavy foundations of tall buildings would instantly snap from the immense stress. Picture a dense, heavily populated city. Every single piece of concrete, glass, and steel instantly becomes unattached from the ground. Surviving that initial jolt above ground is virtually impossible. Your entire surrounding environment practically turns into a massive swarm of supersonic projectiles. Now, think about the largest unattached objects sitting directly on the surface of our planet. Just like the coffee spilling out of your cup, the global oceans are not glued down. When the ocean floor abruptly stops moving, all that water violently surges eastward. This creates towering walls of water hundreds of meters high, tearing across the landscape at those same supersonic speeds. Dense coastal cities like Mumbai would be ground zero for this massive displacement of water. The sheer momentum of the ocean acts like a giant eraser, instantly scraping entire coastal landmasses completely clean. You might be thinking, if the planet only pauses for 5 seconds, couldn't things just freeze for a moment and safely restart? This chart compares 2 types of stops. The curved line shows a safe, gradual slowdown, but the vertical line drops instantly to 0. Inertia does not care how long the stop lasts. It only cares about the violent force created by that instant drop in speed. Notice how the energy level spikes right at the moment of the drop. Dropping a massive planet's speed to 0 instantly creates a staggering amount of energy, and all of it transfers straight into the Earth's crust, cracking it wide open. Even the air is affected. The atmosphere would keep spinning at its original speed, creating global winds strong enough to level whatever is left standing. So the 5-second time frame really does not matter. The physics of an instant halt guarantees complete destruction in the very first millisecond. Let's take a breath and step back into reality. Right now, you are probably sitting in a quiet room, and everything feels completely still. That stillness is an incredible illusion. We are actually on a perfectly balanced, extremely smooth, high-speed ride through space. You can relax knowing that the sheer physical force required to suddenly slam the brakes on our planet simply does not exist anywhere in nature. Instead of worrying about a sudden stop, we can appreciate how perfectly the laws of physics shield us during our daily cosmic road trip. Now, let's test how well you understand inertia by looking around the room you are in. If the Earth slammed on the brakes right now, based on where you are sitting, what is the very first loose object that would go flying past you? Let me know in the comments. Thanks for exploring the physics of our planet with me today. Make sure to subscribe for more videos that help explain the amazing science happening all around.